In this video, we will be discussing about string matching in an array. Given an array of string words, return all strings in words that is a substring of another word. You can return the answer in any order. So what they are saying is that in the input, we are given an array of strings which is words. Now we need to identify all those words from this array which are present as a substring of any other word, right? So for example, if I check for this mass, so I need to find out whether this string mass is present as a substring in any of the other strings, right? If it is, then I need to include this particular string in my answer array, and then at the end I have to return that array in my answer, right? So if you see, if we check for this mass, is this mass present as a substring inside this string? No. Here, no. Here, no. Right? So now we will check for this particular string. Is this present as a substring inside mass? Yes, it is. Here it is present as a substring. Right? So then that means we will include this particular string in our answer. Right? Now we don't need to check it with these strings because this is already included in the answer. Right? Then if we check for this particular string, is it present here as a substring? No. Here, no. Here, yes, it is present here, right? So then that means this particular string will also be included in our answer. Then we'll check for the last string. It is present here, no. Here, no. Here, no. So this won't be included. So this is the final array of strings which we have, and this can be returned as our answer, right? Now the simple brute force approach over here to solve this problem is that, as you see, that each of the word we are taking and we are checking in other words whether it is present as a substring or not, right? So that is what we can do in our implementation as well, that we can first run a for loop of I starting from 0 and going till the end, and we can fix our particular word, right? So when I will be here, we will fix this particular word, right? And then inside this we can run another for loop of j, right? And then that j will run for all the words, and then we can check that if the word of I is present as a substring in word of j. If it is, then we will include this word of I in our answer, right? So this is what we can do. Now, how are you going to identify whether a particular string is present as a substring inside another string or not, right? So as I said, we will be running a for loop of I starting from 0 till n, and then inside this we can run another for loop of j starting from 0 till n, right? Now we need to keep in mind that we do not check a particular word with itself, right? So you'll have to put a condition that if our I is equals to j, in that case you continue, right? But if it is not, then we need to check that if words of I is a substring of words of j, right? Now in C++ it is very easy. What we can do is that we can check that if words of j dot find words of I not equals to the end of the string, right? So if this condition is true, then let us suppose that we have a result vector. So in that result, we can push back words of I, right? And since we have found it, so we can break over here, right? So with this, we will be able to get all the strings in this result. Now, if you were to find out whether words of I is a substring of words of j by yourself, then what you can do is, so let's suppose the string is mass and this is as. Now we need to find out whether this string as is present inside mass or not, right? So what you can do is that you can keep a pointer I over here, a pointer j over here, and then you can check that a is not equals to m. So you will move your j pointer forward. So now you will see a is equals to a, yes, I will move forward and j will also move forward. And then you can check s is equals to s, yes, so j will also move forward, I will also move forward. Now here we are done with the entire string, right? So then that means this particular string is present as a substring inside this string, right? But if let us suppose that our strings were something like b, 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 x, right? This is the main string and the substring that we need to find is bbx, right? Now in this particular case, what would you do? You would have a pointer I over here and j over here. Now you see that these two are matching. So you will move both j and I forward. Now again they are matching b and b. So you will move again j and I forward, right? So now they are not matching, right? Now in this particular case, you cannot just move j forward and keep I here. Why? Because we need to check whether this string is present as a substring, not a subsequence, right? So when they are not matching, then here for this particular string, we considered this much substring, right? So now when this is not matching this, so now we will have to start checking from here, basically from this particular B, right? So our J will move all the way back to this particular B, and our I will move all the way back to this B, right? And then again, we will be checking a string of length 3 over here, right? And then if it is not matching again, then we will check from here the substring of length 3, and then we will check here, right? So basically, for each of the character in this particular string, we are checking the length of this particular string, right? So if let us suppose that the length of this string is x and the length of this string is y, right? So in this particular string, for each of the character, in the worst case, we will check all of these characters, right? So the time complexity of this will go to x cross y, right? X into y. Now in our particular case, we will be checking these words, right? So now it might be possible, this is also a 4 length string, this is also a 4 length string, right? So basically, whatever is this length, our other string could also be of the same length in the worst case, right? So if let us assume that the length of that word is m, so it will be order of m square, right? So basically, this particular thing will be taking a time complexity of order of m square. And then here, if you see, we are running a for loop of I and j. I is running n times. Inside that, j is also running n times. So this is n, this is n, this is n square. And then inside that, m square. So the overall time complexity of this will be order of n square into m square, right? But in our particular case, the maximum length of this words array is 100, right? And inside that, individual word length can be at max 30, right? So this is going to get accepted, right? So let's quickly look at the code. So first of all, let's create a vector string answer. Then we'll run a for loop of I starting from 0, going till words dot size, and then we'll do I plus plus. Inside this, we will run another for loop of j starting from 0, going till words dot size, and then we'll do j plus plus. Then if in any case I becomes equals to j, then we will continue. Otherwise, we will check that if words of j dot find words of I is not equals to the end of the string, then in that case, in the answer, push back words of I, right? And then we'll also break. And then at the end, we can return this answer. So let's run this. So now there are very good algorithms for finding out whether a particular string is present as a substring inside other string or not. So this is basically known as pattern matching, and we have KMP algorithm or Rabin-Karp algorithm, right? So with those algorithms, you can reduce your time complexity. So here, let's try to submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.